People often ask me, "How tall are you, Mr. Hurley?" To which I usually reply, "This tall." Of course, that's not what they really want to know. They want to know what's the measurement in feet and inches. So I usually tell them. But the funny thing is, in most places in the world, they don't measure height in feet and inches, they measure in meters. Now, most people aren't exactly 1 meter or 2 meters tall, so they need to use decimals or fractions to say exactly what somebody's measurement is. So that's what we're going to look at today, how to measure mixed numbers, that is mixed decimals or mixed fractions, on a number line so that we can measure things. And then after we learn that, we're going to find out how tall I am in meters. I've drawn a number line here, and as with most number lines, I have labeled it with numbers. Except on this number line, there's 0 on one side and 1 on the other side. So what goes in the middle? You guessed it, it's fractions. And as you can see, I've broken it up into increments of 10, so the fractions are going to be tenths. So after 0, there's going to be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then 10/10 would be 1 whole, so just 1. So that's how I would label my number line. But we know there's another way to represent tenths, and that's with decimals. We can put numbers in the tenths place when we're representing tenths as decimals, so let's do that on the top. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. So that's how we can represent tenths on a number line, both as fractions and as decimals. Why am I telling you this? Because we can use this information to measure the lengths and heights of different things. For example, fish. I have 3 pictures of fish here, and what I want you to do is measure the length of these 3 fish. At the top we have the California anchovy. Anchovies are fairly small fish, so you can see it's kind of tiny. In the middle to the right we've got the Boccaccio rockfish, and on the bottom we've got the Canary rockfish. Now I want you to measure each of these fish on the number line, remembering that they are all less than 1 meter long, and I want you to use those lines between 0 and 1 to try and figure out how long each of them are. Remember, I've divided the number line up into tenths, so each notch along the line is another tenth more. So press pause to measure your fish, write it both as a decimal and as a fraction, and then press play to check your answers. Okay, let's check your answers, starting with the anchovy in the top right. So if I take a look at the anchovy, the tail starts at 0, and then the nose ends at 1, 2, 3/10 along the number line. So I would say is 3/10 long, 3/10 of a meter. And I can represent 3/10 of a meter either as a decimal or as a fraction. Now looking at the Boccaccio rockfish, it's the largest fish on our screen right now. And you can see that the tail is at 0 meters. And then how many tenths of a meter does it stretch? Well, let's count. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. So the Boccaccio rockfish is 9/10 of a meter long, and you can represent that as a fraction or as a decimal. And finally, the Canary rockfish on the bottom. How long is it? Tail starts at 0, and then we count 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So it's 6/10 of a meter long. What about fish that are larger? There are some really large fish in the ocean. These two, for example. These fish are so large, they are longer than 1 meter. The one on the top is a tuna fish. Did you know that tuna fish can be longer than 1 meter? They're huge. You might think the tuna fish are quite small because when you get a can of tuna, it's only a small amount that you can fit in your hand, but that's only a small amount of the whole tuna. Tuna fish are gigantic. And then the fish on the bottom is called the wahoo, and I just included that fish because I thought the wahoo is a funny name for a fish. Anyways, each of these fish are longer than 1 meter. So what do we have to do? We should start at the first whole amount, that is the amount that's not a fraction, and then count tenths from there. So this is going to be a mixed fraction or a mixed decimal. I want you to start at the nearest whole amount and then count how much extra you need to add. Press pause to try it out. Press play to check your answers. Okay, let's check your answers, starting with that gigantic tuna fish over here. So the largest whole number is 2 meters. And then there's just a little bit more after 2 meters because the mouth goes a bit further. How much further? Well, 1/10. So 2 meters plus that extra 1/10, that's 2 1/10 of a meter. And you can write that as a decimal or as a fraction. What about the wahoo on the bottom? Well, I would start at 1 meter over here and then count how much extra there is. So 1 meter plus how many tenths? 1/10, 2/10, 3, 4/10, 5/10, 6/10, 7/10. So I would say it's 1 7/10 of a meter long. And you can write that as a decimal or as a fraction. What if I gave you the decimal or the fraction and then you had to put it on the number line? Well, if it was a mixed decimal or a mixed fraction, you would again start at the whole number and then count the extra tenths. Let's give it a try. Press pause to try that out and then press play to check your answers. Okay, let's check your answers. On the first one, number A is 0.7 or 7/10. 7/10 is less than 1, so let's just start at 0 and count out 7/10. 1, 2, 3, 4, 5, 6, 7. So 7/10 would go there. What about B? B says 2 7/10. So we're not going to start at 0, we're going to start at 2. And then how many more tenths are we going to add? 7/10. So let's count. 1, 2, 3, 4, 5, 6, 7. So that's where we would put B. What about C? C is 1 40/100. 1 40/100 is the same thing as 1 4/10. So where would 1 4/10 go? We're going to start at 1, and then we're going to add 4/10. 1, 2, 3, 4. So that's where C would go. What about D? D is 8/10. That's less than 1, so we'll start at 0. 1, 2, 3, 4, 5, 6, 7, 8. We'll put it over there. And finally, E is 1 9/10. So we'll start at 1, and then we'll count 9 more tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 9/10. So that's how you would place those on the number line. But what about improper fractions? Ooh, how would we put improper fractions on the number line? Well, I think the best way to do it would be to convert the improper fractions to mixed fractions, since we already know how to put mixed fractions on a number line. How do we do that again? Oh yeah, we need to try counting by the denominator until we get close as we can to the numerator. That would be our whole amount. And then whatever else is extra, whatever else is the remainder, is going to be our fraction bit. And it works something like this. In the top left corner, we're counting by tens until we get to 23. Well, let's try it. 10, 20. Okay, that's as close as we can get. So our whole amount is going to be 2. And then what's the remainder going to be? The difference between 20 and 23 is 3, so 2 3/10. What about 17/10? Again, we're going to count by the denominator until we get to the numerator. Count by 10 till we get to 17. 10, well, that's as far as we can get, because if we get to 20, that's more than 17. So our whole amount is going to be 1, and then what's left over? 7. So it's going to be 1 7/10. In the bottom left, we have 14/10. So we're going to count by 10 till we get to 14. Let's do it. 10, that's as far as we can go. 20 is more than 14. So our whole amount is going to be 1. And then the leftover amount is going to be 4, so 1 4/10. And finally, 35/10. We're going to count by 10 till we get to 35. 10, 20, 30. That's as far as we can go. So the whole amount is 3. And then the leftover bit is 5. So 3 5/10. When the denominator is 10, is there an easier or faster way to figure out how to turn it from an improper fraction to a mixed fraction? Yes. You can look at the amount of tens, and then that's going to be the whole number, and then you can look at the leftover bit, and that's going to be the fraction. So it would be something like this. How many tens are there in 34? Well, there are 3 tens, right? How many tens are there in 78? There are 7 tens. How many tens are there in 123? Some of you said 2 tens, but no, there are actually 12 tens because the hundreds can be turned into tens too. How many tens are there in 345? 34 tens. Okay, so how does that help us? It can help us figure out how many ones there are in these fractions. How many ones are there in 34 tenths? 3. How many ones are there in 78 tenths? 7. How many ones are there in 123 tenths? 12. How many ones are there in 345 tenths? 34. Do you see the pattern? All of the amount that comes in front of the 1 can be turned into the whole number. And then the rest of it is going to be the fraction bit. Let's give it a try. I want you to place each of these numbers on the number line. Well, the first one is 19 tenths. Now, you could just count 19 tenths, but that would take forever. 1, 2, 3, 4, 5, all the way to 19. What's a different way to do it? Remember that we said that when the denominator is 10, any amount in front of the ones place is going to be the whole amount, the amount of ones. So, what's in front of the ones place here? 1. So we'll start at 1, and then we'll count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 1 9 tenths. What about B? It's 11 tenths. What digit is after the ones place in the fraction? 1. So that's going to be our whole amount. And then we'll count how many tenths afterwards? Just 1 more tenth. So 1 1/10. What about C? Well, again, we look at what's in front of the ones place in the fraction, in the numerator. Just 1, so we'll start at 1, and then we'll count how many tenths? 4. 1, 2, 3, 4. Fraction D, 28 tenths. So what digit is before the ones digit? 2. So we're going to start at 2, and then count how many tenths? 8. 1, 2, 3, 4, 5, 6, 7, 8. And finally, fraction E. What digit is in front of the ones? 2. So we'll start at 2, and we'll count how many tenths? 3. 1, 2, 3. 2 3/10. So that's how we put improper fractions on a number line. And now we know how to put decimals, mixed fractions, mixed decimals, and improper fractions on a number line. And we should definitely be able to figure out how tall I am. Okay, now that we know how to measure mixed fractions or mixed decimals on a number line, it's time to find out how tall I am. So, let's find out how tall 1 meter is. Not quite tall enough. Okay, let's find out how tall 2 meters are. Ooh, that's really tall. It goes above the screen. I don't even know how to fit this into the camera. Anyways, that's 2 meters. I'm not as tall as 2 meters. So I'm somewhere in between 1 meter and 2 meters. So let's put in the decimal lines, or the tenths, to find out what tenth measurement I am. So I'm somewhere over here. So I'm going to say I am 1 meter and 9/10ths of a meter. Well, now that you know how tall I am, you can stop asking, and now you can go and finish page 229 in your jump math book and complete the quiz that comes afterwards. The quiz is called something like number line quiz number 1. So that's what I want you to do, and while you do that, I'm going to take tall things off of high shelves, because that's the only thing that tall people do with their spare time anyways, right?